Now let us move on and talk about logarithmic functions. So when we are talking about exponential function, remember it is y equals to a to power x. And if you remember the graph of a to power x, it's either like this or like this. If a is more than 1, the graph increases. If a is bounded between 0 and 1, the graph decreases. The graph of the function passes horizontal line test. The graph of the exponential function passes a horizontal line test. What's the meaning of that? It means that any horizontal line has at most one intersection with the graph. Any horizontal line has one intersection with the graph. So, what does it give me? This is called a one-to-one function, since the graph passes horizontal line test. So we say that y equals to a to power x is a one-to-one function. So what's the use of it? If you have a one-to-one function, you can define the inverse of that function for any one-to-one function. We can define the inverse function. Which is denoted by f with a little -1 on top of it, but just be careful. This doesn't mean that it is equal to 1 over f. This is not true. This is representing inverse function. It is not 1 over f. This is wrong. So you know that any exponential function is one-to-one. We can define the inverse of that function. The inverse of an exponential function is called a logarithmic function. Logarithmic function. So if somebody asks, hey, what is a logarithmic function? You're going to say that, hey, logarithmic functions are the inverse of exponential function and vice versa. You're going to define this function as y equals to log with base a of variable x. If you have exponential function, you can easily graph its inverse or logarithmic function. So here you have, for example, an exponential function like this, 2 to power x. I don't like the graph, it's very sharp here. And the logarithmic function is going to be reflected with respect to y equals to x. So that function behaves like this. This is log of x base 2.